General Mills has a 60% recognition rate. That is to say that 60% of the population would recognize the brand name General Mills. Suppose a manager wants to verify that rate by beginning with a small sample of 7 randomly selected consumers. What is the probability that 6 people recognize the brand? Well, that is the probability that 6 people would recognize the brand. First of all, let's verify this would result in a binomial probability distribution. There are a fixed number of trials because we're going to sample 7 people. In other words, we're going to have 7 trials. The second thing we have to consider is, are they independent? And of course, one person's response is not going to affect anybody else's response here. So we would say they are independent. The third thing, is there one of 2 possible outcomes for each trial? Well, if we consider that the possibility of somebody recognizing the brand as being a success, then a failure would be somebody doesn't recognize the brand. So we have one of 2 possible outcomes for each trial. The last thing we have to consider is the probability of success the same for each person? And so we'll say since this is a 60% recognition rate, the probability of a success we'll say is 0.6, and then the probability of a failure is 0.4. Now, of course, if you're not sampling with replacement, the 60% would not stay steady, because as you sample people, then that probability will change. But it changes so little that we're going to treat it as being independent. So the probability of a success in this case is, let me come down here and write it down here, give myself some more room. The probability of 6 successes, in other words, the probability that 6 people out of the 7 recognize the brand, is 7 factorial divided by, give myself a little more room, divided by 7 minus 6 factorial times 6 factorial times the probability of a success, which in this case is 0.6 because there's a 60% brand recognition rate, to the 6th power because we want 6 successes, times 0.4, the probability of failure, to the 1st power, or 7 minus 6. Now plugging all this into the calculator gets us 0.131 probability that 6 people recognize the brand. Now let's go on to part B. What is the probability that at least 6 people recognize the brand? That means we have to consider 6 and 7. And if there were more trials, we'd have to consider 6, 7, 8, 9. But since there's only 7 trials in this case, we have to consider 6 and 7. So the probability that 6 people recognize the brand and the probability that 7 people recognize the brand. And finally, we'll add those together. So to answer part B, the probability, let's first find the probability of 7 people recognizing the brand. That is 7 out of 7. So that is 7 factorial divided by 0 factorial times 7 factorial. And you might correctly guess that those 7 factorials will cancel. Times 0.6 to the 7th power times 0.4 to the 0 power. And of course, anything to the 0 power is just 1, so those cancel out too. So really, what we're calculating here is 0.6 to the 7th power. Plugging that into the calculator, we get 0.028. Now to answer the question, at least 6, we simply have to add up the probability of 6 plus the probability of 7. So to do that, 0.131 0.131 plus 0.028 gives us 0.159. So the last thing we'll answer is, would 6 out of 7 be an unusually high number of people to recognize the brand? To answer this question, we first want to calculate the mean and the standard deviation. But remember, since this is a binomial probability distribution, we can use our simplified formulas, that is, mean equals n times p, and standard deviation equals the square root of n times p times q. Then, to find out the maximum usual value for this binomial distribution, that would be the mean plus 2 times the standard deviation. So the number of trials in this case was 7. We were sampling 7 people, and the probability of a success was 0.6 because there was a 60% brand recognition. So that gives us a mean of 4.2. Another way to interpret this is that if we randomly sampled 7 people over and over again, on average we would get 4.2 people who recognized the brand. The standard deviation for this distribution, we have to take the square root of 7 times, because there's 7 trials, times 0.6, the number of the probability of a success, times 0.4, the probability of a failure. Calculating that, I get 1.64. So the maximum usual value in this case will be the mean plus 2 times the standard deviation. That is 4.2 plus 2 times 1.64. And throwing all this into the calculator gets us 7.48. So the question was 6 an unusual number of people to recognize the brand? But if 7.48 is the maximum usual value for the number of people that would recognize this brand, we would say no, 6 would not be unusual.